AI is no longer just helping you write code. It is now becoming part of the entire workflow. But if you could control how and when that AI behaves. In this video, we are diving into GitHub Copilot Hooks, a powerful way of customizing and automating your development experience across both Visual Studio Code and GitHub platform. By the end of this video, you will understand how hooks works, why they matter, and how you can start using them in real scenarios. Let us start with the big question. Why do we even need hooks? Agent hooks allow you to execute custom logic at key lifecycle points during an agent session. Remember, this is lifecycle points during an agent session, not the events during SDLC. First, agent hooks can be used for enforcing security. You can prevent risky operations by the agent before they even happen, like blocking a dangerous command such as deleting critical files, running in unsafe queries like drop table. The next one is automate quality. Instead of manually running formatters, linters, or tests, hook can trigger them automatically after changes, ensuring consistent code quality. Then, creation of an audit trails. Every action, every tool invocation, every file change can be logged, which is critical for compliance and traceability in an enterprise environment. The fourth one is context injection. Hooks lets you enrich the agent with project-specific details like environment configurations, APIs, or internal knowledge bases. And finally, to control the approvals. You can define what gets auto-approved and what require human interventions, adding an important layer of governance to AI-driven workflows. So overall, agent hooks transform Copilot from just an assistant into a controlled, secure, and intelligent workflow engine. Now let us look into the common lifecycle events associated with an agent. There are 8 key events that get triggered at different stages of an agent session. It all starts with a session start when a new session begins. Then we have user prompt submit. This is when the user sends a prompt kicking off the agent session. If you are planning an auditing of the user prompts, you can write a hook on the user prompt submit event. Before any tool's execution, PreToolUse is triggered. This is a critical checkpoint where you can validate, modify, and even block some of the actions done by these tools. Once the tool's execution completes, PostToolUse comes into play, allowing you to inspect the results of the tool's execution, log the outputs, and trigger follow-up actions. During processing, the agent might invoke subagents. That is where subagent start and subagent stop comes in, helping you to track and control nested workflows, especially when you orchestrate multi-agents workflow using subagents. These two hooks play a major role. There is a special event pre-compact. This gets triggered when the context exceeds its limit, giving you a chance to manage or optimize what gets retained. And finally, we have the stop, making the end of the session. So if you are looking at this flow, hooks give you visibility and control at every stage, from the moment a session starts all the way to the completion. This is what enables you to build smarter, more controlled, and fully orchestrated AI-driven workflows. Let us have a quick demo on the general hooks. We have the real estate application. Under that, we define the hooks. Hooks can be defined using either /create hook. This is one way of defining a hook. Or go to the customization window, hook section, and specify the requirement for a hook and generate it. These are the two ways you can define a hook, or simply go ahead and add a hooks folder under .github and define the hook as part of a JSON file. The hook definition is straightforward. You define hooks under that the specific event, in this case user prompt submission, and the type, whether you are going to execute a command or not. Here we are going to execute a command which is captured in this sh file, and the file is available here. The overall aspect of this hook is every prompt needs to be tracked and log the action related to the prompt, like the plan, design, API creation, testing, documentation, what exactly the requirement of that prompt. That is what we are doing. We are not logging the entire prompt, just the action related to the prompt. So we are passing the first prompt to agent for adding a new controller handling the administration dashboard creation with a specific requirement. While the agent start working and received the prompt, the hook is in action and it's created a logs folder under that user prompt activity. To identify that this is an API creation, we asked for a controller that is an API creation category and added this as part of the log file. I just stopped the current agent session. So we are going to pass a new prompt to the agent. So our hook is act at the time of user prompt submission. Let us see how the hook track this particular prompt. The prompt is submitted. You can see that user prompt hook at the same time it's tracked these details. There is a design and DB creation. These are the two activities related to this particular prompt. The user prompt tracking is in action and it's able to track it. Every time the hook executes, you will see that warning from the particular hook. In this case, there is an activity log. That is what we needed. If it is a security hardening or the test execution, that will be logged. So this is a simple hook which trigger at the time of user prompt submission. Now let us look at how to configure hooks and work with their input and output. First, we define the hook in multiple locations depending on your use case. All the workspace level hooks will go under .github hooks folder. And cloud setting format, it's under settings.json. User level, you have a global configuration. You can do it under user data folder. And you can define under custom agent, that is a agent specific hook. We will discuss that as part of the next demo. And it can be part of your plugin. So define as part of the plugin also. These are the locations where you can configure a hook file. This flexibility allows you to control behavior at different scopes, from individual projects to organization-wide standard, from a generic hook to an agent-specific hook. Now let us look on the JSON configuration. Under hooks node, you define a lifecycle event, in this case PostToolUse, and specify what action required. Either you can simply run the command directly here, or if it is a multi-step or multiple command required, you can link a sh file as part of the command execution. Coming to the hook input, each hook receives structured input like the timestamp, the current working directory, session ID, the event triggered the hook, the transcript file, or event specific data, all information related to that particular hook. This gives the hook the full context about what exactly happening, which agent is triggered, whether it's an agent specific hook or general hook. On the other side, hook output is a standard output, normally contain whether to continue or stop execution, and if it is a stopped, what's the reason for stop, and a system message to the user, which is displayed as part of VS Code's Copilot chat session, which we observed just now. Along with these three generic output, you have hook specific output which can be captured based on which hook event you triggered. And finally, the exit codes. 0 means success, 2 means there is a blocking error, others is warnings allowing the process to continue, but there is a warning. So overall, the configuration layer is what transforms hooks into a powerful control mechanism, letting you to define in multiple location, simple JSON configuration, flexibility in the output and exit codes. Now let us move to the agent-specific hook example. We are going to use the hook in the GitHub platform. The hook is defined under .github agents as part of the first agent, that is the database expert agent. We have a hook defined as it's a database expert. When there is a user prompt submit, we need to define the command filtered drop statement. If there is any drop statement, don't allow that one. That is the hook. So looking at the code, this is the symbol denotation on the header of the agent. You can say hook, the hook event, and the command to execute. In this case, the command is execution of this script file, which check for whether there is a drop table, database, or schema. Any of these exists. If it is exist, it will not allow the agent to add or execute any such statement. That's a hook we defined. So looking at the pull request which completed just now, this is the pull request we just completed. Going to the commits and expanding to view the agent log associated with this particular pull request. We explicitly asked the agent to drop a particular table and add a new table to the database. As the hook is in action, it stopped here, specifying that I cannot use drop table on user skills. I can create it, but drop is not allowed. If you look at the agent log, multiple places it's captured. There is a strict policy. Drop table is prohibited. The request to drop user skill was not executed. Per the strict schema change policy, drop table is destructive and not allowed as part of this particular execution. This is how you can define an agent-specific hook which can execute as part of agent execution itself. So I hope you are clear on the general hook and an agent-specific hook. Let us look into a few of the best practices and security considerations. Starting from common hook patterns, mainly it can be used for blocking dangerous commands, just like the drop table. Using the PreToolUse or the prompt submission, you can prevent risky operations like deleting critical data or execution of unsafe queries. Next, the auto format after edits. It can be applied in the post tool usage to automatically run tools like a PreToolUse or ESLint to ensure consistent code quality without manual efforts. Audit tools for logging every action and tool invocation. Another key pattern is the approval gating. For sensitive operations, you can request explicit user confirmation, adding a human in the loop using the PreTool hooks. And the last one is Inject project context. In case you want to add some additional information like the branch detail, environment config, version information, you can add at the start of a session. Now coming to the security consideration, always review the hook scripts before enabling them. Follow a principle of least privileges across hooks and agents and everyone. Make sure to validate all inputs to prevent injection attacks. Never hard code any secrets or credentials as part of hook or the agents. You should protect the hook files. Don't allow everyone to modify the hook. Protect the entire .github folder. It consists of custom agent, hooks, scripts, workflows, and everything. It's better to protect the entire folder itself. So for quickly getting started, you can create hook under .github hooks directory and add a simple JSON configuration to execute one command against any of these 8 events. Test your hooks using simple agent sessions and monitor the outputs. To summarize, GitHub Copilot Hooks are not just a feature, they are a shift in how we interact with AI in development. They give you control over AI behavior and ability to run automatic security, code quality test as part of the entire workflow itself. As AI becomes more integrated into SDLC, understanding the usage of hooks is key, and every developer needs to understand how to leverage the power of hooks along with your agents. If you found this useful, don't forget to like, share, and subscribe to TechRill to get more deep dive into GitHub Copilot and AI-powered development. See you in the next one.